Hello, and welcome to Pre-algebra section 1.4 negation homework or problem set. So we're going to just start right away. So question number 1A. Consider the negation facts below. The negation of 4 is negative 4, 3 is negative 3, 2 is negative 3, 1 is negative 2. And so it's asking us what 0 is and what negative 1 is, or the negation of those numbers. So consider where the numbers at the ends of the facts are on the number line. After the first number, how is each number related to the number above it? So if we go ahead and draw our number line really quickly, we have 0, 1, 2, 3, 4, ... We have negative 1, negative 2, negative 3, negative 4, and ... right? Reminding you that these ellipses mean that it goes on from negative infinity to positive infinity. So it goes from negative infinity to positive infinity, right? We can write our positive there. So it's asking, what is the negation? So the negation, as we can see here, means the opposite. Oh, wow. I apologize on that. That is a mistake. The negation of 1 is not negative 2. It is negative 1. And the negation of 2 is negative 2. I apologize. That is a brutal mistake on my part. I will fix that, and so the sheets that you will not have this error on them. So I will go ahead and fix that. So it should be negative 2 and negative 1. So we have the negation of 0 is question, and the negation of negative 1 is question, right? So let's take a look at 0. So what do we notice about 0? There is only one 0. In comparison to the others, when we have 4 and negative 4, there's always the opposite, 3 and negative 3, 2 and negative 2, and 1 and negative 1. Well, we discussed this in the video, and what did we call it? We said that 0 is both non-positive and non-negative, meaning that it does not have a negation. 0 is just 0. It's its own unique property. There is no negative 0. There is no positive 0. It is just 0. So the negation of 0 is, well, it does not exist, but you could also just say it is 0, because negative 0 and positive 0, so positive or negative 0, that's our sign to show positive and negative. We do a positive over a negative, right? So we show that positive negative 0 is just equal to 0. So we could just say 0 for that one. So the negation of negative 1, well, if we look at negative 1, and we look at the opposite of negative 1, because that's what negation is, it's to our opposite, that means it's 1. So the negation of negative 1 is 1. So based on problem A, answer the following. Based on the pattern, what is the negation of 0? We just discussed that, so that is going to be 0. Negative 1 is going to be 1. And if we take a look at negative 2, the opposite of negative 2 is 2. So that's going to be 2. And then of 536, well, if we take our number line and we expand it out as far as we can to get 536, we'll notice that the opposite of negative 536 is going to be our positive 536, meaning that the answer is simply 536, our positive one. So now, on to question number 2. Using the fact that negative x is equal to negative 1 times x, explain why negative 2 times 3 is actually equal to negative 2 times 3 with the parentheses. So let's go ahead and take a look at this. What we can do, we can say, okay, so negative x is equal to negative 1 times x. And what we have here is we have negative 1 right here. We have a negative 1, right, for the negative 2. So we could say that's negative 1 times 2 times 3. And we can actually go ahead and say this is negative 1 times 2 times 3. And so we can have this right here, and 2 times 3 like this. And so that'll be a kind of a form where the negative is on the outside, because we know that -1 is just equal to this negative. So that's why it's equal to that. You can go ahead and write this out in a sentence form as long as you go ahead and understand and as long as you understand and are able to articulate or explain the concept. So using the previous problem, explain why -2 times -3 is equal to 2 times 3. So let's go ahead and look at this. We have -1. We can go ahead and remove this. So we have -2 times -3. And we can say that if we expound this and add the -1s into it, or not add the -1s, but take the -1s out of it, what we can do is -1 times +2 times -1 times +3. Well, what do we get here? We get a negative times a negative. And what does a negative do to another negative? It negates it, which means that it will become its opposite. So that negative will then become a +1. And so that'll be +1 times +2 times +3. And we know that any number times 1 is just going to be itself. So you could just simply rewrite this as 2 times 3. Now C, explain using the fact that the same thing, explain why -4 plus 5 is equal to -4 plus -5. Well, if we remember, we have the distributive property. So what we have here is we have -1 times 4 plus 5. And we distribute this -1 into the 4 and into the 5 such that we get -4 plus -5, right? And so we can go ahead and distribute that 1 out into the 4 and into the 5. And vice versa, if we go ahead and take out this 1 and put it at the front, we get the form -4 plus 5, right? So that's the opposite of that form. And so finally, question number 3. Compute -631 plus 114 plus 631. Well, what we can do here is we can remove this negative to be we can go ahead and remove this to be 100. We can go ahead and reorder this. 114 plus 631 by our commutativeness, and we can go ahead and say it's plus -631. Well, we do know that we can remove this and move it around, and remove this and move it around somewhere else, right? And because we are able to do that, we can simply cancel out this, which is a positive 631, and our negative 631, because the opposites will cancel out, meaning that our answer will simply be 114. So it's a pretty easy way to go about it. Now, what is the sum of all negative integers that are greater than -5? So the sum of all negative integers that are greater than -5. So what is the sum of all negative integers that are greater than 5? So what we have here is we can look at this like a number line. And we can say this is going to be 0. 0 is going to be right here, right? And this is going to be ... Well, we can have -1, -2, -3, -4, and -5. And what we want to know is what is everything greater than 5 combined before 0, because these are all negatives. And so these are the negative integers. So this is as far as the negative integers go from 5. So that's going to be -4 plus -3 plus -2 plus -1. If we go ahead and add this 3 and 2, that's going to be 6, and that's going to be -10. And so that's going to be our sum of all the negative integers that are greater than 5. Because remember, when we're going to the right, the value is getting larger. So the value is getting greater. And when we go to the left, the value is getting lesser or smaller. So, question number 3C. Compute negative 10 plus negative 9 plus negative 8 plus, and the dot, 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 meaning our ellipses, meaning that this pattern continues on to positive 9, positive 10, positive 11, and positive 12. Well, something that we can immediately notice here is that we're going to have the opposites of all of these numbers of negative 9, of negative 8, of negative 7, with 7, 8, 9, and 10. So what we can do is we can go ahead and cancel all the numbers in this ellipses and in here and right here and right here, because these are all going to have its opposites. And so what we're left with is numbers that do not have their opposites. So we have 11 and 12. And so we can simply add 11 and 12, resulting in 23. So compute 210 times 5 plus 105 times 9. So what we can do is we can go ahead and take 210 and we can go ahead and rewrite this. So 210 times 5 plus 105 times negative 9. And so what do we know about 210 and 105? Well, something that's interesting is 1/2 of 210. So 210 divided by 2 is going to be 105. So that means we can take this here. We can go ahead and say 105 times 2 times 5 plus 105 times negative 9. And we can go ahead and multiply these two here. So 105 times 10 plus 105 times negative 9. And now what we can do is we can take this number and we can factor it out such that we get 105 times 10 plus negative 9. And 10 plus negative 9 is just equal to 1. And so our final answer will be 105 times 1, or just 105. And so that's our answer for D. Of course, you could have done the way where you do 210 times 5. And so in that case, you would get 1,050. And then you do 105 times 9, so you do 105 times 9, and you'll make it negative at the end, so you do 5 times 9, which is going to be 45. You do 0 times 9, which is going to be 9, you bring the 4, and then you go ahead and do 1 times 9, which is 9, and this is a negative. So now you go ahead and add those two up, plus negative 945, and that will result in 105. So that'll result in the same thing. It's just a little bit of a more standard process, if you will. So now finally we can go ahead and do E of question number 3. So compute 9,342 plus negative 438 times 719 plus negative 9,340 plus negative 438 minus 719. So let's do something here. So what we can do is we can go ahead and take our 342 and our negative 9,340, and we can go ahead and look at that and go ahead and move that around, and we can go ahead and rewrite this whole problem. So what I'm going to do is I'm going to say 9,342 plus negative 9,340, and then I'm going to say this is plus negative, here, let's go ahead and move this a little bit. I can go ahead and say this is plus negative 438 times 719 plus negative 438 times negative 719. Well, what do I notice here about this thing, I notice that we have a negative 438 here and a negative 438 here. And what do I remember about factoring? That means I can factor these out. But this is 719 and this is negative 719, so I'm not going to factor that out. So because these are the same thing, I will factor them out. So what I will get here is I will get also, before I factor that out, I'm going to take a look at this. And I notice that these are very, very, very similar. There's only a difference of 2. So I just go ahead and mark these out and say 2 plus our new factored form. So I'm going to bring that down here. So our 2 plus our new factored form, which will be negative 438 times 719 plus negative 719. And what do I notice about 719 and negative 719? These are their opposites, so we can go ahead and cancel that out. And that'll be 0, and anything times 0 is just going to be 0, so negative 438 times 0 is going to be 0, and so what we're left with is 2 plus 0, or just 2. And that is our answer for E. And so there we go, that's our final answer, and we have completed the problem set for pre-algebra negation section 1.4. If I messed up, please do mention in the comments. You know, I can always mess up, so if you catch it, it's great. And if I do mess up and you catch it, I know you have been a little bit, and you've been much more attentive, and so good for you. Thank you. Have a great day.